Describing sets with ellipses. If a set consists of many elements, we can use ellipses to help describe the set. Let's look at an example. The set consisting of the natural numbers between 1 and 100 inclusive can be written set of 1, 2, 3, ... 99, 100. The word inclusive means that we include 1 and 100. The ellipses between 3 and 99 are there to indicate that there are elements in the set that we are not explicitly mentioning. Let's look at another example. Let K equal the set of 0, 2, 4, ... 20. Then we have 6 is in K and 18 is in K, whereas 9 is not in K. Using the roster method, we have K equals the set of 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Let's try an exercise. Let L equal the set of 1, 3, 5, ... 25. Use the roster method to describe the set L. Now's a good time to pause the video, try this problem on your own, and then resume the video to check your answer with mine. Okay, so using the roster method, we have the set of 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, and 25. We can also use ellipses to help describe infinite sets. Let's look at some examples of infinite sets. N in this double-struck font, also known as Blackboard Bold, is equal to the set of 0, 1, 2, 3, ... This is the set of natural numbers. Z is the set of ... -4, -3, -2, -1, 0, 1, 2, 3, 4, ... It's the set of integers. E, or 2n, is the set of 0, 2, 4, 6, ... That's the set of even natural numbers. O, or 2n plus 1, is the set of 1, 3, 5, 7, ... It's the set of odd natural numbers. Z plus, or m plus, equals 1, 2, 3, 4, ... is the set of positive integers or positive natural numbers. Let's do one more exercise. Use brackets, commas, and ellipses to describe each of the following sets. Once again, you should pause the video now, try these problems, and then resume the video to check your answers with mine. The even integers 2z, that's the set of ... -6, -4, -2, 0, 2, 4, 6, ... 2z plus 1 is the set of ... -5, -3, -1, 1, 3, 5, 7, ... And the negative integer z minus is the set of ... -6, -5, -4, -3, -2, -1.